All right, so we're live. Hello there, and welcome to today's session. And we are so glad to have you here with us today. And we're just going to briefly run over what you should expect today, and we're pretty much excited as well. Yeah. All right. So today's agenda, we're going to go through why you're here, what you learn. Of course, you get to know the hosts of the online sessions we've been having over the past couple of weeks, and the philosophy behind some of our programs, where you should go from here, and how you can join the community, and introduce the speaker, Q&A session, and what's next time. So why you're here today, of course, you're here to learn from Emmanuel Okorie on how regression analysis is applied in the real world enterprise business scale, whatever you call it. So it's about using regression analysis in industries like sales and logistics and distribution, as well as the financial industry. Of course, regression analysis is one of the techniques of machine learning, and of course has lots of amazing, profitable uses for helping a forecast and so on. So you're going to learn all of that from the master himself. Yeah, so first off, we have this usual advice for machine learning beginners in ML. If you're taking this session, we have some great tips for you. So this is generally more for everybody, or beginners should probably consider doing it more. So you should really, if you're new to the space, just getting started, would advise that you take notes of the terms you don't understand, and because you research on those terms. Sorry, let me switch to presentation real quick. So research on those terms, and engage with the community on social media. So ask questions from experts, author members. The community is so active on social media, Twitter and all of those. You can tweet at people with questions you don't understand, on terms you've gotten and you probably don't understand from here, and they'll be able to help out a whole lot. So the next thing is, of course, take on best practices and good methodologies as much as you can. That will be extremely crucial. So best practices from the master himself is of course, as enterprise knowledge is one thing I would advise everyone to actually take on from here as well. So of course, what you learn, let's go through that quickly. So you're going to learn how regression analysis is applied to real-world decision-making processes in the industry. So we're just focusing on specifically on sales, logistics, and finance industries today. But because that's where the speaker for today has his experience, and of course, it's going to be generalizing more so to other areas where regression analysis is pretty much useful, and you're going to be learning the secrets of using that as well. So of course, how you can get the best out of regression analysis for modeling and forecasting. Sorry for the typo. Modeling and forecasting, of course. And next thing is how regression analysis is used in the digital lending industries like Carbon. Of course, you probably know PayLater from Nigeria. It's perhaps a Nigerian-based company into digital lending, the one finance, I think. So absolutely, you're going to be learning how that works, because the speaker for today was a data scientist at Carbon. And another thing you're going to be learning is how regression analysis is applied to sales forecasting in the real world, as well, of course, business real-world impacts of regression analysis. So yeah. So before we go on, of course, you need to get to know the host for today's program. Just a brief introduction to what we do, why we do, and so on. So, of course, the host for this program, of course, you probably know, are Port School of AI. So what we are, you can find us, of course, on our website, phdschoolofai.org. Why we do this, we release our reports for last year. So we have lots of things we try to connect to our community there. And of course, what we do, most of our activities are shared on Twitter, because it's a really, really amazing AI community out there on Twitter. Yeah, so who we are. So we're a non-profit social organization whose mission is to build a competent and collaborative, AI and data learning community. So we want to solve problems. Well, before solving problems, of course, the talents must be there, as well as the resources. So we want to see how, as a community, we can make sure that knowledge sharing is distributed. Resources amongst people who have, more, and people who don't have are fairly distributed. So more of a community learning type of strategy to seeing how we can build competency in people through mentorship, through resource sharing, through financial support, through whatever support that can help people get competent and making sure that it's not just competency they are seeking, but they are seeking it in a collaborative way. So they are able to work with people in the community to achieve projects, work on goals, and make improve their standard of living, solve problems pretty much. Yeah. So next, of course, why we do this is because Port Harcourt City is situated in River State, so we try to see how we can make River State, data driven and a hub of competent and collaborative AI talents. So once again, you can check the report. And what we do as a non-profit, we are really actively working on actualizing the Sustainable Development Goal 4 of inclusive education, seeing how we can make AI educations in all our programs. We are looking at how we can make sure that we can democratize AI education, make it accessible, make it inclusive for people who are willing to learn. So world-class AI education is actually what we target, and that's why we try to bring in people with lots of expertise to see how they can share knowledge, because that's what we're looking at. How can these people work on our community? How can members in our community get access to world-class education in AI? Whether it's no matter whether it's the expert cost or the financial cost of things, seeing how they can build competency through that as well. So that's what we're looking at. Our story so far, you can find activities on our last report, and of course Twitter, we post most of all the things we do as well. So you can check us out on Twitter, PhD School of AI. So philosophy behind our program. So there are two things we believe. Every learner at the end of our programs must have two key qualities, and that's the leadership quality, because we look at everything we try to plan our programs around is about the need for learners to take personal responsibility for their growth, and not just that, and equally for the growth of others, because we're looking at building competency. It has to be somebody can do stuff, right? But you need to make sure that you can do stuff collaboratively. You can collaborate with other people well, and not just work in silos. So that's what we look at as a community for most of the programs we plan. And empathetic problem solvers. You are expected to look out there and see how you can solve problems. You can make a society a better place and solve the most worrisome challenges with AI technology and, of course, AI education as well. So, but hey, it's about you here now, because one thing we believe, of course, is successful communities are those that put their members first in every plan, and that's what we try to do as a community. So, yeah, where should you go from here? Because it's about you. Yeah, of course, we expect you to join an AI learning community in your region. So, an AI learning community is absolutely crucial for your growth. We had an interview some time back. You can check it on our blog, blog.phdschoolofai.org, with Aurelian Jerome. And one thing he pointed out a lot is join a community as much as you can. Join a community because they would help a lot. People in the community would help a lot, especially with a very active community. So if you have an AI learning community in your region, join the community. If you have skills, talents for contribute. If you don't have an AI learning community, you can start one. Of course, you can make history per se by starting one in your region. Of course, we're in Nigeria, so you look at top communities like Data Science Nigeria, which of course I would always say it's arguably the highest impact tech non-profit in the African continent. So it's really an amazing community you can join. You can also have other local communities like AI Saturdays. Yeah, AI Saturdays. I think that's also localized across cities. As of course, as well as Port Harcourt School of AI, so you also have School of AI in other regions as well. So you can join us. Of course, there's no harm in being in more than one community. So, but the most important thing is that you're getting the most out of the community, as well as contributing back to the community, because that's absolutely crucial for the back and forth progress of both entities, both you and the community. Yeah. So the next thing is. Explore more on the topic for today's session. As much as the notes you've taken and all of those things, we'll have some links in the description. You can just explore more on today's topic. We might not have explicit links to resources, but you can just take the things, the terms you've learned here today, and see how you can just Google things. Like I said, ask questions on social media, tweet out your favorite people. If they're not responding, tweet out the community itself. It's an amazing community out there, the AI and data science community. Most of these experts are willing to, get you up and running and so on. So if you haven't started at all, if you haven't started ML, get started. I mean, that's the easiest, that's the toughest thing to do. But once that's done, it's that's your well on your way, to be very frank. And next thing, of course, ask questions on Twitter. Get in touch with experts and general AI community. I've been talking about community a lot, and because I know how crucial that is for your growth as a practitioner, as a beginner. Yeah, so if you want to join us, the Port Harcourt School of AI, we are going to get active on Slack this month. So you can just use the link on your screen here. And of course, you can follow us on Twitter. I think the Twitter algorithm is pretty great at linking who to follow. I recommend who to follow based on people you just followed. So if you follow Port Harcourt School of AI, there's a likelihood that you can get linked with other experts in the field because we follow them as well. So the algorithm should do a better job, a great job at recommending them for you. So, of course, I think let enough of that. Let's know the sessions facilitator for today. So, today's facilitator is Emmanuel Okorie. Emmanuel Okorie is a data scientist at Maon Technology, and also it was a former data scientist. Is a former data scientist at Carbon PayLater, where he served as a machine learning engineer there. And he's going to be talking today on hidden gems and regression, the applications of regression in analysis in the sales and distribution, as well as the financial industry. Yeah, so he's going to be talking to us on that. And I think later today, if I'm not mistaken, or you could check the links in the description, we are going to be releasing a conversation we had with him. So in an article, we're going to be releasing the insight he has in AI, and so you could follow up from there on some very insightful questions and so on. So that's Emmanuel Okorie. You can come over to his LinkedIn, Okorie Emmanuel, read about him. He has quite a lot of experiences as working both as a data scientist and machine learning engineer, and of course certifications as well. He also has worked on quite a lot of projects too, which I think it's pretty great. I think that's that for Emmanuel. Is going to be taking us on the hidden gems and regression, applications of regression analysis in sales and distribution. So without further ado, I think I'll hand over to Emmanuel. Emmanuel, thank you, and you can join the live stream now.
Yeah, hello. Hi, everyone. Um, Thank you for being here. Um, my name is Okorie Emmanuel, and I'm a computer science graduate from the Federal University of Technology, Owerri. And I currently work as a data scientist in Maon Technology. And I would like to introduce you guys to my presentation titled The Application of Regression Analysis in Sales and Distribution, as well as in fintech industry. So in this presentation, I'll using linear regression to explain or to introduce the concept of regression, as well as its application. In statistics, regression analysis is a powerful statistical method that allows you to examine the relationship between two or more variables of interest. Let's try and paint a scenario. So you're trying to predict the sales, or you're trying to understand how the price can affect the sales. Regression analysis helps you to solve that kind of problems. And while there are many types of regression analysis at their core, they all examine the influence of one or more independent variable on a dependent variable. Like I mentioned earlier, the price here is your independent variables, also known as the determining factors, while the dependent variable is the sales for the given product. Linear regression algorithm is commonly used for predictive analysis and modeling. For example, it can be used to quantify the relative impact of age, gender, and diet on height. So in this case, the independent variables are also known as the determining factors. They include the age, the gender, and the diet, while the outcome variable, the target, what you're trying to predict here, becomes the height. And linear regression model is very simple. It's just a pretty much straightforward algorithm that is mostly used. And the formula here is y equals to b0 plus b1 x1, where b0 is your intercept, and the b1 becomes the coefficient, and x1 that ranges from x1 to xn becomes your predictor variables, also known as the independent variable. And the process of performing regression allows you to confidently determine which factors matters most, also which factors can be ignored, and how these factors influence each other. In my experience, after building, when you're trying to build or work on a machine learning project, you collect your data, you analyze your data, you explore your data, you clean them, pre-process, do the transformation, also apply feature engineering techniques to derive new features from the existing feature sets. You build your model, you do the test splits, build your model, evaluate the results, and you are confident with the result, with model performance. And now you want to present the model to stakeholders. Believe me, stakeholders, they are not so interested in first of all, why the model performance, the evaluation metrics, they are so important. But then you need to, the stakeholders, they are interested in seeing what are the factors that matters the most. So you, after building your model, after doing your feature engineering, you ended up creating about 20 features for your model. At the end of the day, the model might pay attention to about 5 factors or 5 variables, and pay lesser attention to the remaining 15 variables. So in presenting your model results to stakeholders, you need to look at you need to explain the factors that affect the most to the business stakeholders. And how can you achieve that? You can look at the coefficients and also the feature importance from linear regression. And for this presentation, I will be looking at a case study for fintech industry, also and also for the sales and distribution industry. So for fintech industry, we will be exploring how linear regression serves as a tool for predicting customer lifetime value. Fintech companies, they invest in customers to generate revenues and be profitable. So different kinds of investments they do includes acquisition costs, offline ads, promotion, discounts, as well as other personalized offers. Naturally, these actions make some customers super valuable in terms of lifetime value, but there are always some customers who pull down the profitability. And these customers need to be identified and action taken accordingly. So what are the actions here? Let's say, for instance, you spend so much money to acquire new customers on your plan, and at the end of the day, you having looked at or assessed your revenue over a certain period, you might want to understand the customers who are your real customers or the ideal customers to focus on. So through employing linear regression to forecast or predict the customer lifetime value can serve as a major solution to your problem. So how does it work? First of all, you start by defining the right time frame for customer LTV value calculation. So let's say, for instance, you want to predict your customer lifetime value for the next 3 years. So the time frame becomes 3 years, and in this case, the time frame becomes 3 years. And the next step is to create the feature list you are going to use to predict the future. And the feature list, we are going to get to that in the next slide. The next step, you calculate the lifetime value for training the model, you build and run the machine learning model and evaluate the results. Now, creating the feature list. There's a term called RFM, and we are going to explore how it affects the LTV prediction. RFM basically stands for recency, frequency, and monetary value. To calculate for recency, to calculate the recency, basically you need to find out most recent transaction dates for each customer and see how many days they are inactive for. So you want to predict, in our case, you're trying to predict customer lifetime value for the next 3 years. And you start by looking at the last transaction for the past 6 months. To derive the recency, look at the most recent date of transaction per customer and extract the difference, the date difference from the latest date the customer made a transaction. You compare it and save the value. That becomes your recency. The next one is the frequency. To derive the frequency value, you need to find out the total number of times the customer made a transaction. Transaction might include the loans, the bill payments, investments, as well as other possible transactions you have on your platform. So you look at the total number of times. This is basically the volume of transaction made, and for the monetary value, you extract the value for each transaction done over the period. Then what's the approach? You start by building a regression model for existing customers. You take a transaction, including the demographic information about the customer over a period. That becomes your independent variable. And the total revenue generated over the period becomes the dependent variable. And you build a regression model on the data. So let's try to paint a scenario, a real-life scenario. You have in your database, you have about 10,000 customers who have been on your platform who have been making transactions for the past 3 years. You have this data. You're trying to create an LTV model for them. So you start by looking at for each of those customers on your database, look at the last 6 months transaction, as well as the demographic information about the customer. Demography includes the age, the employment, the income range, as well as other important features you have in your database. And you look at the transactional data over the past 6 months, and that becomes your independent variable. Then to derive the dependent variable, you take a sum of the revenues generated over the past 3 years and save it as your dependent variable. So now you're trying to look at you're trying to understand how customer transactions, how customer activity relates to the revenue generated by those customers. For this, in applying linear regression, regression analysis to predict customer lifetime value, it helps us to, one of the benefits of adopting these techniques is to help us categorize the customers according to their customer lifetime value prediction. And the marketing strategy is important here, considering their customer lifetime value can help to figure out most profitable customers. But how companies make profits from them will depend on the adopted marketing strategy. So one of the strategies that I would advise companies to try to adopt is, first of all, from the prediction, the numbers are continuous or real value. You can create a band or a category for the prediction, maybe either high, middle, and low. So for those customers that fall under the low category based on the prediction or the output, you can try to, in a way to improve those customers, you try to encourage them to increase their frequency, the frequency. So let's say, for instance, this certain cluster of customers, they are not generating as much revenue as you expect them to do. You can encourage them by sending personalized offers, discounts to enable them to start making transactions on your platform. Then for the mid-value customers, you can try to improve retention rates. There are tons of offers that you can advertise. You can give to these customers that would enable them to improve retention and frequency. Then for the high-value customers, these customers, they have always been making transactions and their transaction value is very high. You can help them by introducing or giving them personalized offers that can improve retention, because you cannot afford to lose these customers. Then I'm going to speak on another application of regression analysis in the sales and distribution industry. So one of the major challenges faced by sales and distribution industry is trying to optimizing supply chain management. Like in any other industry, the current focus on digitalization is transforming also the supply chain management and improving the efficiency of the supply chain management. Improving the efficiency of the supply chain is of great importance for many companies. And there are several examples where data analytics and machine learning can be beneficial for supply chain management. Example includes within demand forecasting and warehouse optimization. Given the vast amounts of data collected by industrial logistics, transportation, and warehousing, being able to harness this data to drive operational performance can be a game changer for companies that use this. One of the case studies that I would like to discuss is a major project that my team are working. And the project has to do with inventory optimization. You're trying to we solved a challenge faced by one of our clients, and the challenge basically was to optimize their localized and centralized warehouse storage of goods. On the other hand, you know very well that substantial local storage is very, very expensive. What this means is that the individual depots owned by the distributor, they can't afford to replenish or to stock up each of the individual depot pan Nigeria to the highest level to feed them to the brim, because of number one, the risk involved theft, disasters, as well as other factors. So it's very, very expensive. On the other hand, relying mostly on the central storage and running the risk of sold out items in the stores is another factor. So what this means basically is our clients, they have a central warehouse. Like the warehouse stands as the major channel of supplying major channel for supplying goods down to the individual depots per night. The individual depots, they are sparsely distributed across the country. So we only have and our clients only have one central warehouse. So warehouse optimization is thus a great importance, and having access to accurate sales forecast would be extremely useful information. So I'm going to discuss the approach and how we are able to solve this problem faced by our clients. So first of all, we listed out our data requirements, what we need in order to solve this problem faced by our clients. So the data set that the data requirements includes the logistics data. Our clients, they have numerous fleets. Fleets includes the truck, bike, van, and each fleet, each vehicle has an each vehicle stored on them, and the API tracker returns real-time information about the real-time information of the current location of that particular vehicle, and the data they get or they pull from this sensor, what they use it for is just to monitor whether the truck is in transit or the truck has gotten to the delivery destination, or the truck has returned back to the pickup location. So this is what how they process this data, just real-time monitoring. And the next data requirements that we demanded was local and the centralized warehouse data. So this data includes the stock level, the current stock level of each of the individual depots, as well as the warehouse, the central warehouse depot stock level. And we also we extracted the longitude, the coordinates of each individual depot and the central warehouse. Then the last data we collected was the sales history for each depot, because each depot stands as a channel for both inventory and sales. So they sell out goods at a higher rate, but is not constant across all the individual depots pan Nigeria. So you find out that some depots they sell at a higher rate, while some depots sell at a lower rate. So our goal here is to try and manage or optimize the demand and supply. Where there is in a location where there is higher demand, we should send more stock to that location, and location where there is low demand but they have a higher stock, we have to pick stock from those locations and supply to locations that need that have high demand but low stock. And by doing this, our goal is to make sure that every depot they always have optimal stock, or they have the stock that can meet their needs, and we can't afford to let each of the individual depots to run out of sales opportunity. So the approach we used, my team and I used to solve this problem was, first of all, we built a forecast model using linear regression to predict demand. And to be one of the components, the variables that we used to build the forecast model using linear regression includes the pricing, the historical price, the information about the product, also the channel, because we realized that there are different channels in each depot, and the channels include both wholesale retailers, and wholesalers, they buy at a very rapid rate, while retailers buy at a lower rate. We also looked at seasonality, because from our explorative data analysis, we got to realize that seasonality affects the sales of our clients, and seasonality includes their sales rates increases by the end of the year between November, December, from let's say from October, November, December, but December is usually their peak. So from explorative data analysis and data visualization, we got to discover these insights from the data, and we built a linear regression model to help us to forecast the demand for each individual depot. So the forecasted value is fed into an engine, a logistics engine that automates the process of finding the optimal truck that can carry the quantity, as well as allocating the pickup warehouse or the pickup location. Remember, I mentioned earlier that the goal is to make sure that for each depot that sells at a higher rate but have a lower stock, we first of all need to go and search for nearby locations, nearby depots that have higher stock but lower sales. So we pick stock from those locations based on the suggested quantity. We find the optimal truck by reading the real-time data provided by gotten from the sensor, the EMI, the tracker installed on the fleet. Then with the data we calculate, we calculate the optimal vehicle that can fulfill this transfer, and we initiate the transfer. So this process, believe me, this process is an automated process and is a standalone application. We adopted a microservice approach. So for the model, for the focus model, is a service that runs on its own. The model has been trained and it has been evaluated, and we deployed the model. Then other data processing activity is hosted on another microservice, and this was how we were able to solve this major problem faced by our clients, which was basically trying to inventory and manage demand and supply. So we have seen the regression analysis, and it's a very important tool. And we've also learned its application in both fintech industry, which basically our case study was to understand how we can use regression analysis to predict customer lifetime value. And we also learned about using regression analysis to optimize supply chain management. So here I would leave the floor open for anyone who has questions before I conclude. So in the absence of no question, I would like to wrap up this session. And as data is crucial for regression analysis, big data is coming back in organization as a crucial term to explore AI capabilities. Machine learning requires that the right set of data be applied to a learning process. But my big advice to everyone out there is that you don't need big data to use machine learning algorithms. But big data can help you improve the accuracy of your algorithms. Thank you very much. Okay. Yes. So the model that was built, the question here is the model that was built for forecasting, does it also automate the delivery to the warehouse? So we, in terms of automation, I think the approach we used here was to, first of all, predict the quantity needed by the individual location, and the suggested quantity is used to plan shipments. And the shipment plan includes finding the truck, allocating, also searching for the nearest location that can supply to the depot that is in need. In a situation where nearby the location, because we need to make sure we want to prioritize nearby transfer first of all before moving to the national warehouse or to the central warehouse where every other where manufactured goods are first dumped before redistribution to individual locations. So the model basically, what the model does is to predict demand for individual depots, and the quantity is used to search for locations that can supply to that location, to the depot that is in need. In a situation where the depot, where nearby locations they don't have enough to release, because if they release whatever thing they have, it will affect their own sales, because we don't want to rob Peter to pay Paul. So in that situation, we now navigate direct to the central warehouse to initiate the transfer. So the model is a standalone system that will send in suggested quantity, and there is a microservice that does the automation of allocating the truck, finding the nearby location, loading the vehicle, just to loading the truck with the right capacity, and raise the shipment on a dashboard for the logistic manager to approve. Does that answer your question? Yes, 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 sure. Okay, thank you very much.